Hello, PLP Geometry, and welcome to the last lesson of Unit 5. So this is number 7. So we are finishing with parallelograms on the coordinate plane. How fitting that Unit 5, which talked about parallelograms, and then also talked so much about the coordinate plane, would now finish with the 7th lesson in the unit on parallelograms on the coordinate plane. Parallelograms on the coordinate plane. Perfect. Okay, so I'm going to give you some background story, remind you of some things about parallelograms, special parallelograms. We're going to talk about formulas to use, and then we're going to do one example problem. Okay, so let's talk about what's called the hierarchy of parallelograms. So I'm going to start over here on the far left. I'm going to draw a parallelogram, right? So a parallelogram is like a rectangle on its side, right? Or slanted, I should say, not on its side, slanted, right? So this I'm drawing is a parallelogram. Parallelogram. Okay, so there are two important things about parallelograms that you have to remember, right? The first thing is that the opposite sides are parallel. So opposite sides are parallel. So that would be like these two sides being parallel and then these two sides being parallel, right? And let's recall that on a coordinate plane, to show parallel lines, you have to look at slopes and see that the slopes are equal. We'll talk about that in a little bit. The other thing that's important is that the opposite sides are also congruent. So again, these opposite sides congruent, 1 dash. These opposite sides congruent, we'll put 2 dashes. And again, to determine if two sides are congruent, we have to know the lengths or their lengths. And to find length on a coordinate plane, we use the distance between 2 points. Okay. Now, from a parallelogram, you could branch off 2 separate ways. Okay? So the first way I'll do in green is a rhombus. So remember, a rhombus looks similar to a parallelogram, that it's on its side slanted, but instead of having 2 pairs of opposite sides congruent, all the sides are congruent. So this is a rhombus. And again, to know that you are a rhombus, you have 4 congruent sides. So we'll put dashes across all 4 sides. Now, the other branch from a parallelogram would be a rectangle. So a rectangle would be more like a parallelogram, but straight up and down, right? Not slanted. So this is a rectangle. Because this rectangle is straight up and not slanted, that means all the angles are right angles. So it has 4 right angles. Here, 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 and here. Which means that in your rectangle, sides are perpendicular, and on a coordinate plane, to show that sides are perpendicular, we use slope. Again, just kind of foreshadowing what's going to happen. And then lastly, if both of these are true, then you are a square. So remember that a square has the properties of both rhombuses and rectangles. So a square does have 4 congruent sides. So 1 dash, 1 dash, 1 dash, 1 dash. And it has 4 right angles. Sorry about that. 4 right angles. So I'll put right angle boxes in all 4 corners. Boom, 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 boom. So this is the hierarchy of parallelograms. This question like this has been on the state test before, so again, it might be important to think about. But again, this is what your parallelogram could be in terms of the different special parallelograms. Okay, so now more about how do we approach these problems on the coordinate plane. So this is going to be formulas to use. So formulas to use. So the first thing, okay, we're going to look to see is if we have parallel sides, right? That's what verifies that we're a parallelogram. So we're looking for parallel sides. And if the sides are parallel, which is this symbol of like an 11, we are going to use slope. And again, for lines to be parallel, their slopes must be equal. Now you're going to see that we're going to do a lot of this on the coordinate plane. So our slope on the coordinate plane M is your rise over your run. Okay, now to go right along with parallel lines, so because we also want to see if there's any right angles, right? We need to check to see if our sides are perpendicular. Perpendicular sides. Remember, that's the upside down T. And again, to show if sides are perpendicular, we look at slope. But in this case, we're looking to see if our slopes are opposite reciprocals. So for example, we're looking for a slope of like A over B and negative B over A. Okay? And then last but not least, again, we need to see if we have congruent sides. Again, congruent sides. And to do this, we're looking to find distances. Now remember, I showed you in the last video to find a distance. Let's create that right triangle, find the x change and the y change, square them, add them, and take the square root. However, to make life even simpler for you, right, when we are doing this, we can use our rise and our run as our x and y. Remember that the rise is the y direction and the run is the x direction. So we can find the distance by taking the run, that's terrible run, by taking the run and squaring it, plus the rise and square it, all under a square root. Now, to help make things less confusing, you can ignore negatives when you do this distance stuff. So ignore any negatives. Because again, when you square them, it all becomes positive. So these problems are very routine. You approach them the exact same way. So again, we're going to go over how we do that in the next slide here. Okay? Perfect. Okay, so our example here. So example. Okay, so it's just going to say identify the special parallel. Identify the special parallelogram. We have T at 1, -5. We have U at 5, 3. We have V at -3, 7. And we have W at -7, -1. Okay, so I'm going to continue this on Desmos. I think you will have to graph them on your worksheets. So again, you can use Desmos to help you with that, right? So say bye-bye to the black screen. Okay. All right, so here's my Desmos. Remember to zoom out one time. So I'm going to use the polygon command. So polygon, parenthesis. And now each ordered pair gets its own parenthesis. So 1, -5. And then we do 5, 3. 5, 3, not 30. And then we do -3, 7. And then we do -7, -1. Okay, and there's our picture. And I bet you're thinking to yourself, Mr. Chappell, that's a square. I know it's a square, 100%. Okay, good for you. But you still have to show me your work, right? So let's talk about what you would do on your paper, right? So again, there's going to be a graph given to you. You need to graph this. So I'm going to graph it myself. I'm going to do it right over here. So here is my graph. So 1, -5. So that's where T is. I'm going to put T there. 5, 3. That's where TU. So U is here. -3, 7. It is a bummer that Desmos doesn't label the points when it graphs them like that. I don't know how to control that. So that's V. And then -7. -1. -7, 1, 2, 3, 5, 6, 7, -1. And that would be W. And again, on my picture on my paper, that's what it would look like. Okay, and again, I'm thinking that this is a square. And if I'm thinking it's a square, that means it's going to have 4 congruent sides, and it's going to have 4 right angles. Okay, so what we're going to start off by doing is we're going to find the slopes of all 4 sides. So I'll do this in a different color. Let's change it to dark blue. Okay, so the first thing I'm going to do is I'm going to find the slopes. And this will be set up for you on your paper. So the slope symbol is an M. So we're going to find the slope of TU. Now, let's be aware that opposite sides are going to be the same because this is a parallelogram. So the slope of TU is also the slope of VW. Right? These sides are going to be parallel. TU, VW. Okay, so let's count. We're going to count the rise and run from T to U. So up, 1, 2, 3, 4, 5, 6, 7, 8, right, 1, 2, 3, 4. So up, 8, right, 4. So again, I'm going up, 8, right, 4. So I might put that on my paper, up, 8, right, 4. Okay, so that simplifies to 2. So if I had more space, I'd continue on, but it simplifies to 2. So there we go. Okay, and now let's find the slope of UV. Now the slope of UV will also be the slope of WT. Okay, and again, they're going to be parallel because it is a parallelogram. So let's go from, I'm going to go from V to U, so I get to go left to right. So from V to U, I'm going down 1, 2, 3, 4, and right 1, 2, 3, 4, 5, 6, 7, 8. So I'm going down 4 and right 8. So again, I'm going down 4 and right 8. So -4, +8. Well, -4 over 8, if you don't know, type it in Desmos and press the fraction button, but they're both divisible by 4. That gives you -1/2. And if you look here, we have, and I'll do it in yellow, we have a slope of 2 and a slope of -1/2. Those are opposite reciprocals. It's a gross yellow, sorry. Those are opposite reciprocals. And if those lines, if those slopes are opposite reciprocals, then that means that these 4 angles are going to be right angles because all the sides are perpendicular. So opposite reciprocal means we have 4 right angles, which means we are a rectangle. Rectangle. Okay, so that's the first thing that we do. Okay, step 2, I'll do it on purple. Step 2, I'll do it right here. We're going to find the distances to see if we have any congruent sides. So let's find the distance of TU. Now I know that TU will be congruent to VW, so I'm also finding the length of VW. So remember I said let's take the run and the rise. So this 4 is the run, this 8 is the rise. So 4 squared plus 8 squared. I don't need you to use decimals, just get what the inside becomes. This is 16 plus 64, which is the square root of 80. Okay, so those 2 sides are the square root of 80. Now let's do the same thing for the second side lengths. UV, which will be the same as WT. So UV and WT will be the same. Again, let's take the rise and the run, not the simplified one, but the original one. 8 and -4. Now I'm going to ignore the negative. So 8 squared plus 4 squared. That is 64 plus 16, which again is the square root of 80. And now, if you look at these 2 numbers, they are the same. And because these 2 numbers are the same, that means that all 4 sides are congruent. So we have 4 congruent sides. And if you have 4 congruent sides, that makes you a rhombus. And now, if you are a rectangle, and if you are a rhombus, then your final answer is square. And this is a square. That's a square. So this is how you do every problem. Graph it, find the slopes, find the side lengths, and then determine are you a rectangle, are you a rhombus, and if you're both, then you're a square. All right, I'll be more than happy to help you in class. Good luck.